Hi, this is Bill Punch. This video is one of a series of videos used to support Michigan State University's Introduction to Computer Science using Python, Selection1. This particular video will cover the concept of selection. There'll be a subsequent video that covers other versions of selection. Let's go ahead and get started. So, selection is our first control structure. And selection is essentially the ability to decide during the running of a program which of a set of statements to run. It is one of the most fundamental aspects of computer science. You have to have some sort of selection operation in any programming language. And the best way to look at it is perhaps to look at a picture. Typically what we've done in our sequential operation, which is all we've ever seen before, is we execute a statement, then we execute the next statement, and so on and so on and so on until we get to the very end. What we'd like to change is to have it be the case that we do statement, 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 and then we come to this Boolean expression. We've seen Boolean expressions before. They evaluate to capital T true or capital F false, and depending on the result of the Boolean expression, we'd operate and execute only one set of statements or potentially the other set of statements, whichever one is appropriate. We have a true branch and a false branch, and then having finished, and this is very important, we pick up where we left off and we do the execution of statement, statement, statement. So we start with some statements, boom, 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 evaluate a Boolean expression, pick a direction, execute the statement, pick it up, carry on. This is a very powerful control structure, and it's our very first control structure. So let's take a look. The first thing I want to say is that in general for Python, there's a special statement called a compound statement, and all of our control structures are going to be showing up and looking as a compound statement. And a compound statement is going to look something like this. They all look roughly the same. They have a keyword. The keyword could be if or while or for, and this is a Python keyword that we have, followed by a Boolean expression, which you can evaluate to true or false. And then at the end, marking the end of the compound expression is a colon. Those are the three elements, and so the keyword would change. And then indented underneath the colon are a series of statements, and they are all indented by a tab. And the way Python interprets this is that these statements are part of this compound statement. They belong to it, and they are grouped together because they have the same level of indentation as every other statement in the compound expression. So every one of these statements underneath the colon is indented at exactly the same level. This series of statements indented underneath is called a suite, S-U-I-T-E, of statements. And all of our compound expressions are going to look something like that. And the first one that we're going to have is our if statement, and this is the way an if statement looks. This is our first version. We'll actually see two other versions as we go on in the second video, the continuation of this. So here's the keyword, the if statement, some Boolean expression, and a colon, and then underneath the suite, this can be anywhere from as many as you want, as many statements as you want. And each one of the statements in the suite is indented to the same level underneath the compound statement. So no matter how many are here, they're all indented at the same level. And for the particular compound statement, the control statement if, we interpret it in the following way. When we come to the if statement, we evaluate the Boolean expression. Right? And the result of the Boolean expression is either capital T true or capital F false. Depending on the result, if the Boolean expression evaluates to true, then we evaluate the suite of statements indented underneath the Boolean expression. If the Boolean expression is false, then what we will do is we skip the suite of statements and do none of them. And either way, whether true or false, we then move on to the statements that follow and continue evaluation. So there were some statements in front of this. We evaluated those. We evaluated the Boolean. If the Boolean was true, we evaluated the suite. If the Boolean was false, we skipped the suite and we move on and continue to evaluate statements below. Here's an example of a simple evaluation of an if statement. We have a variable called my_int. We set it to some value, say 27. We ask the question, is my_int less than 100? Right? That is a Boolean expression that results in either true or false. In this case, it would be true. If it's true, then we would evaluate the statements located underneath, indented to the same level, and evaluate that, and then evaluate the one underneath. Let's go ahead and try that. So, is my_int less than 100? It is. We evaluated the print statement and went on. What happens if we had changed this value to 1,000 and reevaluated? In that particular case, the Boolean expression would be false. Either way, and so as a result of it being false, the print statement was not executed. But either way, whether true or false, if true, we evaluate the print statement and then move on with the next statement. If false, we skip the statement and move on to the next statement. So the print statement, or whatever part of the suite is there, only the statement is evaluated only if it's true. Here's another example. What happens if we want to convert something between 0 and 1 to a percentage? So if we, example, had put in a float value of 1, here's our conditional, our Boolean expression. If the value of float is greater than or equal to 0 or less than or equal to 1.0, we would evaluate these two statements located under the header, and then having executed that, would move on to the next one. If this resulted in false, we would skip these operations and move directly on to the one afterwards. So let's see both of those examples. So here's 1.0. That should follow in the range between 0 and 1.0 since it's less than or greater than or equal to. If we evaluate that, we get the percentage. We convert it by multiplying 100 and then printing out the result. If we had set this value to 10, and we now evaluate the expression, the Boolean should be false. We should skip those two suite statements underneath, execute the one that's following, moving on.